for Red 12.5, compound events. A compound event is any probability that has multiple events. For example, flipping a coin would be a single event. Flipping a coin and then rolling a dice would be a compound event. Or spinning a spinner and then spinning a spinner a second time. That would be a compound event because there's multiples. Compound events are used a lot of times when you have multiple things going on. Like when we were doing our sample spaces and our tree maps, we had multiple events. Those would become compound events. First one we're going to talk about is the birth of 4 kids. Many of your families have a lot of girls or a lot of boys in your family. What would be the probability of that happening? Now there's one of 2 ways you can solve this. You can first write out all the possible options and then count the ones that are the outcome you're looking for. Or you can do the math. So, for example, if on the birth of 4 kids, what would be the odds of you getting all girls in your family if you had 4 kids, one after the other? Well, the probability of the first one was 1 out of 2. The second one would be 1 out of 2. The second one would be 1 out of 2. And the second one would be 1 out of 2. So you might ask yourself, well, why isn't the probability of getting 4 girls just 1 out of 2? Well, there's a whole lot more outcomes than that because you could have 1 girl and 3 boys, or 2 girls and 2 boys, or the girls could come in any order. Maybe it went boy, boy, girl, girl, or girl, girl, boy, boy. Those are 2 different outcomes. So that's one reason why it's really good to write them all out, and we're going to do that here in a minute. But if I just want to know the probability of a family having 4 kids and them all being girls, you would simply multiply their individual probabilities together. 1 times 1 times 1 times 1, 1. 2 times 2 is 4, times 2 is 8, times 2 is 16. So that means there are 16 possible combinations of children, and one of them is all girls, which makes sense. There's only one way to get all girls. So if I were to write all these out, I could say that the first kid was male, and then the rest were girls. Then I could say the first kid was a boy, and then they were girls, girls, boy. Then I could say male, girl, boy, girl. You could say boy, girl, boy, boy. Notice I'm changing the last one each time to make it easy. Then I can go boy, boy, girl, girl, boy, 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 girl, boy, boy, girl, boy, 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 boy. Then I can repeat all this with a girl first. And then what if I went girl, boy, 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 girl, 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 boy, girl, girl, boy, girl, 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 boy, boy, girl, 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 boy. I have that one. Oh, I already duplicated that one. See how difficult this is? Because now I'm starting to duplicate them, and I know I don't have them all because they're supposed to be 16. And I've only got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 13 of them. So I know I'm missing 3 of them. But this gets confusing. I'm already confused. And you've got to be confused because that's a whole lot of M's and F's. That's why using this method makes a little bit more sense. Okay? In some cases, when they're not so complicated, it might make sense to list them all out. If you're talking drinks at Sonic, or sandwiches at Subway, a dice and a spinner, where the outcomes are very different, it might be easier to list them. In our case, it's more trouble than it's worth. Okay? So let's try another example. Remember, these are compound events. Easiest method, find the outcome, find the probability of the first event, find the probability of the second event, and multiply them together. That is the easiest and quickest method. So, over here we've got a quarter, we've got a spinner, which is kind of missing its spinner, isn't it? And we've got a bag of marbles. Now, that quarter has 2 outcomes. So we can either have heads or we can have tails. 2 outcomes. The spinner has 3 outcomes. We got red. That's not red, that's orange. That's orange, purple, and white. So we have 3 outcomes. And then our marble bag has a red marble, a green marble, and a yellow marble, so we have 3 outcomes there. Now we learned from a previous lesson that our fundamental counting principle, we can multiply these together to find out the total outcomes. 2 times 3 is 6, times 3 is 18, so we have 18 total outcomes. Okay? In any combination, that means flipping the quarter, spinning the spinner, and pulling a marble out of the bag. From that, I can figure out all these different combinations by making a tree map. If I wanted to find the probability, I could just calculate it out. So what would be the probability of flipping tails, spinning orange, and pulling a yellow marble so that I spell toy? Tails, orange in the spinner, Y for yellow marble. Well, for the tails, it's 1 out of 2. For orange, it's 1 out of 3. And for the yellow marble, it's 1 out of 3. Multiply those together, and I get 1 times 1 times 1, 2 times 3 times 3. I get 1 out of 18. That 1 would change if maybe you said, well, it doesn't matter what comes on the coin, but it matters what's on the spinner and the marble. Or what if it said I got 2 different marbles? That's how your probability changes. Okay? If you wanted to list them out, tree map is your best option. Start with your smallest, heads, tails, or you can start with your largest if you wanted to. Doesn't really matter. And then I'd have orange, purple, white, orange, purple, white. And then I have 3 coming out of that one, 3 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 out of that one, and 3 out of that one, representing red, green, yellow, red, green, yellow, red, green, yellow, red, green, yellow. Oh my goodness, this is time consuming. Why would anybody want to do all this? You wouldn't. That's why you have the fundamental counting principle. Okay? Remember, compound events, to find the probability of an outcome in a compound event, multiply the 2 individual probabilities together, or make a tree map and count. Have a good evening.